We'll now continue with section 1.5 and discuss several applications involving linear equations. The first topic that we want to discuss is how to solve a linear equation for one variable. Our example says to solve the following equations for the specified variable. All of the equations are formulas that arise in application problems, and they are linear in terms of the specified variable. So our first example is P is equal to 2 times L plus 2 times W. And this is the formula for the perimeter of a rectangle when L is the length and W is the width. And we're asked to solve this expression for W. So solving for W means that I want to get the W by itself on one side. So let's go ahead and get started by subtracting the 2L from both sides. And so we have P minus 2, we'll write that L a little differently, is equal to 2 times W. And then we want the W by itself, so we need to get rid of this 2 in front of the W. We can get rid of that by dividing both sides by 2. And so our expression is going to equal P minus 2 times L over 2 is equal to W. And so usually we turn it around the other way. I'm going to write it W is equal to P minus 2L over 2. And so in doing that, we have solved our perimeter formula for W. The second part of the example asks us to solve the formula A is equal to P times the quantity 1 plus R over M raised to the MT power. And we want to solve this for P. And this is the formula for compound interest. P is the principal, R is the interest rate, T is the time in years, and M is the number of times it compounds a year. And so we want to take this expression and solve it for P. So to begin, we want P by itself, so we need to get rid of all of this. And so I can do that by dividing. Since it's attached to the P with multiplication, I can come in and I can divide both sides of the expression by this quantity. Now, in actuality, at this point, we have solved it for P. I'm going to flip it around, so I'm going to say P is equal to A, and then on the denominator, we have 1 plus R to the M raised to the MT power. And so it is solved for P at that point, but we may want it to look a little nicer. And so one thing that we can do is we can take this denominator and pull it up to the numerator and cause that exponent to become negative. And so that may be a slightly better way to write it. A is equal to 1 plus R over M raised to the negative MT power. All right, and our third example, S is equal to 2 pi R squared plus 2 pi RH. This is the formula for surface area of a right circular cylinder where the radius is R and the height is H. And so let's see, we want to solve this for H. So we want to get H by itself. We can go ahead and subtract this term off. So minus 2 pi R squared. So that's going to give me S minus 2 pi R squared is equal to 2 pi RH. Remember that we're solving for H. So we can divide by the 2, the pi, and the R. And so again, I'm going to turn it around. H is equal to S minus 2 pi R squared over 2 pi R. So we can definitely see that type of problem where we're given a formula that we'll be using in applications, and we may need to solve that formula for a particular variable. We also have several other application problems that we want to look at. This one says that the distance from Shreveport, Louisiana to Austin, Texas by one route is 325 miles. So right now, as we read through this, I'm going to jot down that the distance is 325 miles. If Kevin made the trip in 5.5 hours, so we know that the time is 5.5 hours, what is his average speed? And so we are trying to find the speed. So let's look at this. We know we have a formula that says distance is equal to rate times time. We know the distance is 325 miles. We've already said that. The time is 5.5. We already wrote that down as well back here. And so we can definitely use that formula. Distance is equal to rate times time. And we can say that the speed is going to be the rate that we're looking for. And so let's plug in what we know. We know the distance is 325. The r is what we're looking for, and the time is 5.5. And so we can solve this by dividing both sides by 5.5. And so our rate will be 325 divided by 5.5, which, plugging that in your calculator and rounding to the nearest tenth, would give you 59.1 miles per hour. All right, and let's try one more problem. Julie invested $1,500 in a risky high-tech stock on January 1st. On July 1st, her stock is worth $2,100. She knows that her investment did not earn interest at a constant rate, but she wants to determine her average rate of return at this point in the year. So what is the average annual rate of return that she has earned so far? So we know that her initial investment was $1,500. So in terms of a interest formula, that's going to be the P. That's our principal. That's what we started with. And we know that the interest that she earned is going to be the difference in the P and the $2,100. So she actually earned what? $600 in interest. So I'm going to write that down somewhere. We know that she earned an interest of $600. We know her time because we're looking at a time from January 1st to July 1st. That's 6 months. And so our time would be 6 months out of 12, or 1/2 years. And so let's think about a formula that's going to help us to solve for the rate. We have a formula that looks like interest is equal to principal times rate times time. So I is equal to P times R times T. So let's see if we can make this formula work. We know the interest is 600. The principal was 1,500. The rate is what we're looking for. And the time is 1/2. And so we can go in now and solve that expression. If I multiply 1,500 times 1/2, that's going to give me 750. And then solving for R, we would divide both sides by 750. And so 600 over 750 is going to give you an interest rate of 0.8. And so roughly, as a percentage, which might make more sense, we move that decimal 2 places to the right, we're talking about an 80% average rate of return on her investment.